Hi folks, we're going to take a look at the solution to page 140, number 2 from the unit assignment. Okay, so they give us this function f at x, except we notice that one of the coefficients is unknown, so that's our k. And they tell us that when f is divided by x minus 3, the remainder is negative 10. And they want us to find what k is. Okay, so here we see that we're dividing by a linear expression, and they're asking us a question only about the remainder. So that should tell us to use the remainder theorem. Okay, so let's just apply the remainder theorem and see where that takes us. Okay, so in order to get the remainder of f when we divide by x minus 3, that's equivalent. So the remainder is equivalent to just finding f at 3. Okay, but in this case here, they give us the remainder. We know that the remainder is negative 10. Okay, and so now let's calculate f at 3. So we got 3 to the 4 plus k times 3 cubed minus 3 times 3 minus 5. And lo and behold, we have an equation that we can solve because the only unknown left is k, and in fact it's even a linear equation. Okay, so let's go ahead and do that. Here we got negative 10 equals, so 3 to the 4th is 81 plus 27k minus 9 minus 5. Okay, so let's bring everything to the other side, and I'm feeling a little lazy, so we'll use our calculator here. Make sure we don't make any silly mistakes. So here, what do we have? We have negative 10. So we have minus 81 plus 9 plus 5. Okay, so negative 77. So here we have negative 77 equals 27k. And k then must be equal to negative 77 over 27. Okay, so bit of an annoying answer, but works nonetheless. Okay, so here in part B, they're asking us to determine the remainder of f when it's divided by x plus 3. Okay, but we know now the full function f at x, so we know that that's equal to x to the 4th minus 77 over 27x cubed based on what we got in A, okay, minus 3x minus 5. Okay, so if we want to determine the remainder when dividing by x plus 3, so again, we use the remainder theorem again. We don't actually have to do a division by x plus 3. We just have to evaluate the function f at, in this case here, negative 3. So here, let's do that. F at negative 3 equals negative 3 to the 4th minus 77 over 27 times negative 3 cubed. So actually, that's good news. We'll get rid of that fraction. Minus 3 times negative 3 and minus 5. Okay, so here again we have 81. Here, negative 3 cubed is negative 27. So that reduces the 27 in the denominator. And we end up with a plus 77 here. Then plus 9 minus 5. Okay, and let's calculate that out. So what do we got here? We've got 81 plus 77 plus 9 minus 5, and that's equal to 162. Okay, so just to recap here, we were looking for a missing component of a polynomial, and we use the fact that we are given the remainder when we're dividing by a linear factor. A linear expression. And so we know that the remainder is just equal to the polynomial evaluated at that a value, if we think of this as x minus a. Okay, so from that we generated an equation to find k, and then here was just about applying the the remainder theorem directly, since we knew we were dividing by x plus 3, so that means we just have to input